Hi students, welcome back to class. In the previous class, we talked about chemical combination, the definition of chemical combination. We talked about how chemical bonds are formed. And we told us that we have ionic bond or electrovalent bond which are formed from transfer of electrons. We also mentioned about covalent bond, and we said we have two types of covalent bond, which are pure or ordinary covalent bond or dative and dative or coordinate covalent bond. In today's class, we are going to continue with covalent bonding. We will talk about hydrogen bond, we will talk about van der Waals forces, and then we will talk about metallic bond. So let's continue. Covalent bond. Recall that covalent bond is formed as a result of sharing of electrons. Sharing of electrons. And we said that we have two types of covalent bond. We have pure or ordinary covalent bond, and coordinate or dative covalent bond. We said pure or ordinary covalent bond is formed when there is equal sharing. Let's assume we have atom A having an electron, then atom B also having an electron. When they combine together, they share the electrons, and then you have A, B. Now, this is a typical pure or ordinary covalent bond. However, pure or ordinary covalent bond is also subdivided into two. We have homonuclei and heteronuclei. Now, in homonuclear bonding has to do with atom of the same element. Most especially it occurs with diatomic molecules like hydrogen, oxygen, chlorine, fluorine, nitrogen, etc. This is how the bonds are formed here with the aid of Lewis dot diagram. With the aid of for homonuclear now, we said it occur with atoms of the same element, e.g. oxygen, chlorine, hydrogen, nitrogen, etc. Now let's check how bonds are formed with chlorine. Chlorine, remember, has an electronic configuration of 287. 7 is the outermost electron, or we call it the valence electron. The valence electron. Now we use for us to be able to show this bonding very well, we are going to be using the Lewis dot diagram. The Lewis dot diagram deals with only the valence electron. We represent the valence electron using the Lewis dot diagram. So we have chlorine. This is 2, 2, 2, 1, making 7. Then we also have another chlorine combining together. Now when they combine together, it forms something like this. Then it forms a single covalent bond. So in a typical chlorine molecule, you have two chlorine atoms combining together. In a typical chlorine molecules, you have two chlorine atoms combining together to form a single covalent bond. A single covalent bond. Another example is that of oxygen. Now oxygen is having 2,6 as the electronic configuration. When oxygen reacts together, we have two oxygen, 2, 2, 2, and then you have another 2 here, 2, 2, and 2. When they combine together, you have something like this: 1, 2, 3, 4. That means you have got these two together. They are sharing the same electron, and this one is still having 2 on top. then you have this one like this. Now, so in an oxygen molecule, you have a double bond. So an oxygen molecule is a covalent bond, but it's having a what? A double bond. As a result of the fact that this one brings two electrons. The first oxygen molecule brings two electrons. The second oxygen molecule brings two electrons, and two electrons make a bond. So you have the first bond and the second bond. So another example that we are going to do is that of the nitrogen. Nitrogen. So in a nitrogen atom, the electronic configuration is 2 5, since nitrogen is atomic number 7. So you have, when nitrogen molecules are combining, this is how it is. You have 2, 1, 2, and 3. You also have 2, 1, 2, 3. When they combine together, you have something like this: 1, 2, 3, 4, 5, 6. So you have, this one is bringing 3 electrons, the other one is also bringing what? 3 electrons. So they are combining together to make 6. That means that they will have 3 bonds: 1, 2, 3, and then something like this. Please take note that in a nitrogen molecule, you have triple covalent bond there. However, this bond that we use for bonding, they are called bond pair. The electrons that is used for bonding, they are called bond pair. However, the electrons that are not used for bonding, like for example in nitrogen now, a nitrogen atom uses 3 electrons to bond, remaining 2 electrons with it on top. Now these 2 electrons that is remaining, that was not used, is called a lone pair of electron. So in a nitrogen atom, 3 bond pair and what? You have 2 bond pair and what? A lone pair of electrons. So nitrogen atom is having a lone pair of electrons on it. Now, having said that, this is for homonuclear. Like we said, homonuclear covalent bond has to do with atoms of the same element combining together to form a covalent compound. So these are, now we have said chlorine forms a single bond, oxygen forms a double bond, while nitrogen forms a triple bond. Now let's go to the heteronuclear. Heteronuclear pure covalent bonding. Now for the heteronuclear, atoms of different elements share electrons together during this combination. An example is hydrogen chloride. Now when you have hydrogen is having 1 electron, and then chlorine is having 1, 2, 1, 2, 1, 2, 1. Now in their combination, this one is dropping its electron for sharing, this one is also dropping its electron for sharing. So you have, and then finally you have HCl. So in a typical hydrogen chloride combination, hydrogen and chlorine combination, you have a single bond joining them together, and we have shown it here. Again, we can also have that of water. Now that means hydrogen and oxygen combining together to form water. The combination is like this: you have oxygen, you have hydrogen. Now in water, now recall that you have water is H2O. Then you have hydrogen, and oxygen. Now this one has 1 electron, this one has 1 electron, and then this one is having 2 6. That's 6 electron. 1 2 1 2 1 and 2. Now for them to share together, this electron combine with this, and this electron combine with this. So you have something like this. You have 1 2, you have 1 2, and then it will give us H H. So after bonding, the oxygen is having a lone pair of electron on it. So this is the structure of water, and that's why water has a bend shape or a V shape. Now this is an example of an heteronuclear combination where you have atoms of different element combining together. Now in another one, we can also have that of nitrogen combining together for in case of ammonia. In ammonia now, you have nitrogen combining with 3 hydrogen. Now in this case, remember nitrogen is having 5 electrons in the valence shell. So we put 2 here, the lone pair of electron that is on nitrogen. Now the 3, one will combine in the first hydrogen, the second one will combine with the second hydrogen, and the third electron will also combine with third hydrogen. So you have something like this: H, H, and H. And that is why a typical ammonia compound has a trigonal planar shape. A trigonal planar shape. You can see from here, and then having a trigonal planar shape. And that is why the nitrogen that is linking them together is also still possessing a lone pair of electron on it. So, in a nutshell, for heteronuclear deals with combination that has to involve atoms of different elements combining together. We have seen in the case of hydrogen and chlorine forming a single bond, and on that chlorine you have 3 lone pairs of electron. We have seen in the case of water having oxygen combined joined to hydrogen, 2 hydrogen atom, and of course on that hydrogen atom you are having a lone pair of electron there. And of course in the case of ammonia, we have also seen that nitrogen atom joining with 3 hydrogen atoms and still having a lone pair of electron. So this is heteronuclear combination. Now quickly we go to that of coordinate covalent bonding. Coordinate covalent bonding or dative coordinate covalent or dative bonding. Now, in a coordinate covalent bond, don't forget we are still dealing with covalent bonding. Covalent bonding involves sharing of electrons. In pure or ordinary covalent bond, you will see that there is equal sharing. Atom A is dropping 1 electron, atom B is dropping another electron, and they are sharing it together. In coordinate covalent bond, however, you have atom A having an electron, but atom B do not, and they still share the electron together. So atom A is having an electron, atom B is not having, but A and B are sharing the 1 electron that is have together, so that A becomes positive and B becomes negative. So this is the summary of coordinate covalent bonding. Now this is evident in 2 ways. Number 1, when you have an ammonia, when ammonia combines with an acid, for instance. Now we show it here by saying that, recall that in ammonia that we did the other time, the nitrogen is having a lone pair of what? Electron on it. So we can now say that the lone pair is here, and of course is connected to hydrogen, 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 and is combined with this. So this lone pair of electron is shared. So it is used to form bond with this, so that it can form Na4+. Now this is a typical coordinate covalent bond, where nitrogen is having a lone pair of electron that is shared and is used for bonding. Another example is that of water that we did. When you have water, H2O with an acid again. In this case, the in this case, the oxygen here is also having a lone pair, as we have seen here the other time, where you have a lone pair here and here. Now the lone pair is used to form bond with this, so it can form H3O plus. So these are typical example of a coordinate covalent bond, where atoms having lone pair of electron in them donate the electrons for sharing so that they can form bond. Now also note that apart from this, every complexes are joined together by a coordinate covalent bond. Every complex. An example of a complex is where you have tetraamine couplet 2. When you have a tetraamine couplet 2, this is an example of a complex ion. This complex ion is having copper at the middle, which is we call it the ligand, and of course you have NH3, and then you have H3N 2 plus. Now this central atom and the ligands are joined together by a coordinate covalent bond. This is the central atom, these are the ligand. They are joined together by a coordinate covalent bond. So all complexes are joined together by a coordinate covalent bond or a dative bond. So when you see a question bringing out the bond and asking you what is the bond that exists between these complexes, it is a coordinate covalent bond. So far we have looked at covalent bonding. We have said covalent bonding involves sharing of electrons, and then we said we have two types of covalent bonding, and that is pure or ordinary covalent bond and dative or coordinate covalent bond. We said in ordinary covalent bond that electrons are shared equally, and we said we have two types of ordinary covalent bond, which are homonuclear and heteronuclear. For homonuclear, it exists between atoms of the same element, and then for heteronuclear, it exists between atoms of different elements. And then we've said that we have coordinate covalent bond where only one of the participating atom is having electrons for sharing. And then we said this can occur when ammonia reacts or bonds with an acid, as shown in the other one. And of course, we also said that coordinate covalent bond is also found in complexes. Coordinate covalent bond is also found in complexes. In the next slide, in the next lesson, we are going to look at hydrogen bonding, metallic bonding, van der Waals forces. So enjoy your day. Continue to learn chemistry. Have a nice day.